Okay, welcome back. It is day 199 of coding every single day. So, um, today, back in lab, um, beautiful Monday. I worked more on the Wi-Fi thing. Um, it's like there, kind of. So like in Unity, in the scene, I have just still a bunch of ray traces going around the room. They bounce 4 times and they immediately go back to a receiver. And as I walk through them, they get reflected and the values change. And I actually have some graphings that reflect the movement pretty well. Now it comes down to details of like being able to pick up on like just hand movements through just waves. And the thing that sucks about having no data and having to do this all virtually is I can't actually prove that it's going to work in real application. So I bought my own stuff to do this on my own. So this is if it'll focus. So that is a Wi-Fi like Arduino board that will act as either a receiver or a sender. And so, oh, so since anything can send packets, basically my laptop, computer, phone, router, anything, packets are everywhere. On my thing, I can just send a loop of pinging something and sending packets out to it. And so those packets will travel to a router as long as I'm not on Ethernet, which I'm not. So those packets will have to go out somehow. Um, and then on the other side of the room, this is until I get my Intel 5300, which is on its way. But just for now, um, I have I have this. I took it out of the packaging just for you, um, which I should be able to just flash it with some code. I think. Actually, no. I might have to. I think I'm gonna have to plug it into my laptop, and there's a Linux toolkit that I can use to make this a receiver that won't give me phase information that the Intel 5300 would, and won't give me as detailed information, but I think it did say it will give me amplitude, which is what I'm trying to train on. So, so I should have that information. The amplitude is, from my understanding, is just you send out these waves at a certain strength, and they get received at a certain strength, and then the true difference between those is the amplitude. And so, based on movement in the room, the amplitude changes for every single wave that's out there on every single channel or frequency, and you can use that to map movement. So I'm going to try that as well as keep working on a simulator. So yeah, gonna work on that throughout the week. As for actual code behind me, I did a lead code, which was searching a 2D array. And so the brute force way is obviously very simple. Of you just go through. And so my first idea was just do a binary search on each row. But that also seemed like if it was every single row was sorted, but not every single column was sorted, I'm assuming that was the most efficient thing. But both of them were sorted. So what I tried to do is I was trying to do go down the diagonal, and if the diagonal value wasn't equal to the target and the target was greater than that value, then anything on that on that vertical or horizontal and everything behind it would be invalid. It wouldn't be the target. The thing was, is I was assuming it was a square matrix. On a rectangular matrix, there's gaps because there could be it could be a one line, and I check the first value, and it could be less than like all the values on that line, and so uh, I just don't check it at all, that whole entire line. So it was just flawed. And so the actual approach that I did actually solve, I watched a video and then solved it after my recording, is just having starting in the bottom left corner, or I think top right's fine, and just saying, is this value, is the target less than or greater than this value? If it's less than this value, then you can eliminate the entire bottom row because that's all going to be greater. If it's greater than that value, then you can eliminate the whole column. And you just keep doing that and chopping off full row or column until you find the target. So that was the most efficient solution. I think it was like O of n plus n time or something. So yeah. Um, yeah, that's all I really have. Actually, it definitely wasn't O of. I think it was O of because O of n plus n would be just going through it. That would be the brute force. So the time complexity would be O of log n plus log m. I think maybe. I don't know. It was efficient, much more efficient than the brute force. So yeah, that is all I have. I'm going to go to the gym and then maybe play around with this receiver and sender and see if I can get some information from laptop pinging to receiving on this little board. So I'll let you know how it goes tomorrow. Anyways, tomorrow's day 200, and hopefully we won't see 300 days.